All right, welcome back everyone. Let's go through the answers to simplifying rational expressions when we're given a product and we're canceling out factors and the domain changes. So we want to be able to simplify the following products of rational expressions, noting any domain changes that occur during any step, and then finally state the difference in the domain between the original expression and the final. So the first example we're looking at is 15x minus 35 over 6x plus 5 times 6x plus 5 over 7 minus 3x. So I'm going to start by looking and noting that I can factor a 5 out of the top left. We have 15x minus 35. I can pull a 5 out, and I'm left with 3x minus 7 over 6x plus 5 times 6x plus 5 over 7 minus 3x. Now, I could cancel right now, but I'm going to save all the canceling for the next step. I'm going to notice that the 3x minus 7 and the 7 minus 3x are the same but opposite signs. So if I pull a negative out of the top left to make that a minus 5, then this will be a 7 minus 3x inside there over 6x plus 5 times 6x plus 5 over 7 minus 3x. Now we can go ahead and cancel. So we cancel the 7 minus 3x's, the 6x plus 5's, and we're left with just a minus 5. So let's note the domain of the first three. The domain here, we have 6x plus 5 cannot equal 0. And 7 minus 3x cannot equal 0. So subtract the 5 divided by 6. X cannot equal negative 5, 6. And x cannot equal, we'll subtract the 7, negative 7 over negative 3. So x cannot equal positive 7/3. The negatives cancel there. So the domain is the set of x such that x cannot equal negative 5/6 or positive 7/3. And the domain in the final is all real numbers. There's no domain restrictions here. So if I want to note the domain changes, or where are these the same and where are they different, these are equal everywhere except when x is equal to negative 5, 6, or 7/3. Cool, that one wasn't too bad there. Let's go over to part B. We have 2x squared minus 9x plus 9 over 3x minus 12 times 4x divided by x squared minus 3x. We'll start in the top left. We had 2x squared minus 9x plus 9, and we want to factor that. So I've got a 2x, and then parentheses, and then I'll leave an x. For a 9, I probably want a 3 and a 3. Let's see, 2x times 3 is 6x, and 6x and 3x. I want a minus and a minus to multiply to be positive 9, and then the minus 6x and minus 3x will be negative 9. On the bottom, we can factor out a 3, so 3x minus 12 becomes 3 times parentheses x minus 4 times, on top we have that 4x, and we'll have this as over. I can factor out an x from the bottom. X squared minus 3x we can factor as x times x minus 3. So let's note here 3x, or I guess we could just say x minus 4 cannot equal 0, so x cannot equal 4. And then x cannot equal 0 from this factor right there. And then x minus 3 cannot equal 0, so x cannot equal 3. So the domain of the original expression or function is the set of x such that x cannot equal 0, 3, or 4. Let's go ahead and cancel where we can. We can cancel an x top and bottom. We can cancel an x minus 3 top and bottom. And we are left left with 4 times 2x minus 3 on top, and then we are left with 3 times x minus 4 on the bottom. That's it. We can't simplify any more. So the domain of this new one is x cannot equal 4. And so we could say that these are equal unless x is 0 or 3. They're the same at 4, right? Their domains are, if you plug in 4, both of them are undefined, so there's no change there. But at 0 and 3, the new expression is defined while the original is not. Right, we've got a couple more to go here. Oh, this looks like a lot of factoring. All right, part C. I'm going to do the domain stuff off to the left here after I do the factoring. So we have 3x squared minus 13x minus 10 over x squared minus 2x minus 15 times x squared plus x minus 2 over 3x squared minus x minus 2. And in the top left, we have 3x squared minus 13x minus 10. If I factor this, I'm going to want a 3x and an x in there. The minus 10, I either could do a 1 and a 10, or I could do a 2 and a 5. Let's try the 5 and a 2 here. This will give me a minus 15x, and then a plus 2x would be minus 13 in the middle. In the denominator, x squared minus 2x minus 15 can factor as x. X and the two numbers need to multiply to be 15, so a 3 and a 5, or a 1 and a 15. The 3 and the 5 will work to negative 2 if I do a minus 5 and a plus 3 there. The top right, we have x squared plus x minus 2. Here we go to factor this, and we'll have x in the first positions, and then we need a minus 2, so a 2 and a 1, and we'll need a plus 2 and a minus 1 to add to positive 1 in the middle. In the denominator, we have 3x squared minus x minus 2, so we'll need a 3x and an x in the first positions. We'll need a 2 and a 1 in the second positions. If I put a 2 in the second and second factor and a 1 in the first, I'll have a 6x, and then a 1x. That's not going to work, to a 1 in the middle. So I'll put a 1 in the second factor and a 2 in the first. Then I'll have 3x, and then I need minus 3x and plus 2x would give us a minus x in the middle. Whew. All right, so from this we can look at our domain of these before we cancel anything. So we have x plus 3 cannot equal 0. X minus 5 cannot equal 0. 3x plus 2 cannot equal 0. And x minus 1 cannot equal 0. So x cannot equal negative 3. X cannot equal positive 5. X cannot equal negative 2/3. And x cannot equal positive 1. So the domain is the set of x values such that x does not equal any of these numbers, negative 3, negative 2/3, 1, or 5. All right, let's go ahead and cancel some factors here. The 3x plus 2's can cancel, the x minus 5's can cancel, and the x minus 1's can cancel. After we do that, we see that we're going to get x plus 2 over x plus 3. And the domain here is the set of x such that x cannot equal negative 3. The other numbers are now okay. So we can say that the original and this new expression are equal unless x is negative 2/3, 1, or 5. Those are the differences in the domain. All right. Wasn't too bad. The factoring was a bit much, but the rest wasn't too bad. Let's look at this last one here, part D. We have 6 minus s over s squared minus 3s minus 10 times s squared plus 5s plus 6 over s squared minus 3s minus 18. The top left, 6 minus s. I just want to flip that around. I'm going to make that a minus s minus 6. I could have done that later, but I just like putting the s first there, so that's kind of nice. The denominator, s squared minus 3s minus 10. Factor this as s in the first positions. We need a 5 and a 2. We want a minus 5 and a plus 2 in the second positions to add to negative 3 and multiply to negative 10. We've got s squared plus 5s plus 6 in the top right. Factor this. We want s in the first positions. We want 6 in the second positions, or multiply to 6. So a 3 and a 2 will multiply to 6 and they add to 5. So positives for both of those. The denominator, s squared minus 3s minus 18. S in the first positions. And then we want like a negative 6 and a plus 3 would multiply to be negative 18 and add to negative 3 in the middle. So I can note the domains here. We have s plus 2 cannot equal 0, so s cannot equal negative 2. S minus 5 cannot equal 0, so s cannot equal 5. We've got s minus 6 cannot equal 0, so s cannot equal positive 6. And then s plus 3 cannot equal 0, so s cannot equal negative 3. So the domain of the original is the set of s values such that s does not equal negative 3, negative 2, 5, or 6. Go ahead and do our cancelization. Now we can cancel an s minus 6. Let's remember there's a minus 1 in front of that. Cancel the s plus 2. And cancel the s plus 3. So after that, we're left with negative 1 on top over s minus 5 on the bottom. And this new domain is the set of s such that s cannot equal 5. And the other domain restrictions are now gone. So the simplified form and the original form, we say these are equal. Unless s is the other numbers, negative 3, negative 2, or 6. Cool. That is it. That is everything for these problems, this group of problems. Thank you so much for watching, everyone. We will